The table shows values from an exponential function in the form y equals a b to the x, where a and b are positive constants. Which statement best describes the exponential function? So without doing too much, let's analyze what y equals a b to the x means. A is always going to be your starting point, your initial value, and b is going to be your common ratio, which you multiply every single time to get from one number to the next. In this case, my initial value is going to be 0.6. Okay, so I'm starting out with 0.60. It looks like every single time to get from one number to the next, I'm going to be very careful. I don't just divide by a quarter. I divide by a quarter over an interval of 2, but I don't think that's going to be necessary. I mean, what we definitely have is we have decay. So what's going to happen here is b is going to be some type of decay where we divide by 4 every 2, which means I guess I could legitimately say that I divide by 2. So if I were to force like a 1 in there and put a 0.30, that would work. So what I have is I'm dividing by 2 every time. So you're a half. So that's the equation I came up with. Is that what it wants me to do here? No, it just wants me to answer some logical questions. The function demonstrates exponential growth. No. The function demonstrates exponential growth. No. The function demonstrates exponential decay because a is in between 0 and 1. Well, that's not why. That just happens to be the case here, but that's not why it's exponential decay. It's exponential decay because b, my common ratio, is between 0 and 1. So it's easy to select C based off of the numbers that I got, but C is not why it's exponential decay. D is why it's exponential decay. DK Donkey Kong.